Hey team, welcome back. It's great to see you. I'm here from Dr. Coolcat's crew, and today we are diving into something that, let's be honest, can be a real headache on the GED Science test, graphs. But don't worry, we're going to give you a super clear, super simple playbook to absolutely crush them.
So let's just get right to the heart of it, shall we? You're staring at a practice test. You see a graph, and your first thought is this designed to trick me? Right? Like it's some kind of puzzle box designed to be confusing? You are not alone in feeling that way. So many people have that little voice of anxiety saying, oh man, I'm going to misread one little thing and get it wrong.
And here's the deal. Graphs aren't just some small side quests on the GED's science test. No, they are a main event. But you know what? That's actually great news. Why? Because mastering them is a skill, not some random talent you're born with. And today, we're handing you the playbook. You see, this isn't some kind of ambush. The folks who designed the GED are literally telling you right up front, hey, we're going to test this. It's a whole section called Using Numbers and Graphics in Science. So everything we do today, we're training for the exact game we're going to play on test day. Okay, you ready? Let's get into the good stuff. We're going to give you your new secret weapon. It is a simple 4-step method, a little routine you're going to run every single time a graph pops up on your screen. We call it TAPS. And trust me, this is your key to unlocking the right answer every single time. So here it is. TAPS. That stands for Title, Access, Patterns, and Specifics. Now listen, this isn't just a friendly suggestion. Think of it like a pilot's pre-flight checklist. It's a routine you run every single time. Burning this into your memory is probably the single biggest thing you can do to jack up your score on these questions. Seriously. First up, T is for title and task. Before your eyes even glance at the squiggly lines or the bars, you do two things. 1, read the title of the graph. What are we even talking about? 2, read the question itself. What is your exact mission? What are they asking you to find?
Okay, next up, A for axes and all units. Look at the x-axis and the y-axis. What do they represent? And, this is so important, what are the units? A number like 10 is totally naked and meaningless, but 10 centimeters or 10 degrees Celsius, now that's real information. You have to say the units out loud. Never skip this.
All right, then we get to P for patterns and parts. Now you can finally look at the graph itself, but don't zoom in yet. Just look at the big picture. What's the overall story? Is the line generally going up? Is it falling? Is one bar just towering over all the others? You're just getting the general vibe, the main trend, in a single glance. And finally, we have S for specifics. Okay, now it's time to zoom in. This is where you become a data detective. You find the exact number they're asking about. You do the calculation, like finding the slope, and you make absolutely sure that your answer comes only, and I mean only, from the data you see right in front of you. No outside knowledge. All right, that's the theory. But you know what? You don't learn how to ride a bike by just reading the manual, right? You got to get on and pedal. So let's do that. It is time to put TAPS into practice. We're going to run a couple of live drills with some classic GED-style problems. Okay, deep dive number 1. We're starting with a real classic, the line graph. These almost always show how something changes over a period of time. And 9 times out of 10, the question is going to ask about the rate of change, which is really just a fancy way of saying slope. You got this. So here's the setup. A lab is recording the room temperature. At 8 a.m., it's 10 degrees Celsius. By 12 p.m. noon, it's warmed up to 18 degrees Celsius. The question is simple. What is the average rate of change? Let's fire up the TAPS method and solve this thing. Okay, let's walk through it. T for task. Our mission is to find the rate. A for axes. Our units are degrees Celsius on the y-axis and hours on the x-axis. P for pattern. Pretty simple. The temperature is going up. And now S for specifics. The change in temperature, the rise, is 18 minus 10, which is 8 degrees. The change in time, the run, is from 8 to 12, which is 4 hours. So, rise over run. 8 degrees divided by 4 hours gives us 2 degrees Celsius per hour. See how that works? It's a system. It's not a trick. Nice work. Let's level up. Deep dive number 2. This time, we're tackling a bar chart. Now, bar charts are all about comparing different things, different groups, different categories. And sometimes they'll throw a little math at you and ask for something like a percent change. So check this out. We've got a bar chart showing the average height of some plants, measured in centimeters. The control group, with no special treatment,
grew to 16 centimeters. Plants with fertilizer A hit 20 centimeters, and fertilizer B plants shot all the way up to 25 centimeters. Right away, you can see the P for pattern, right? Fertilizer B is the clear winner. But the test is going to want you to get specific. So, what is the percent increase in height from the control group to the fertilizer B group? Okay, here's how we do this. Step 1, find the difference. 25 minus 16 is 9 centimeters. That's the amount it grew. Step 2, and this is the part everyone forgets, you divide that difference by the original starting value. So we divide 9 by 16. That gives you 0.5625. To turn that into a percent, you just multiply by 100, and boom, a 56.25% increase.
Okay, this next point is absolutely critical. You look at that chart and it's so tempting to say, fertilizer B causes plants to grow taller. And yeah, it probably does. But on the GED, you have to be super careful. A graph only shows a correlation, a relationship. It doesn't prove causation. Think about it this way. A graph might show that when tutoring hours go up, test scores also go up. That's a correlation. But can you say for sure, from that graph alone, that tutoring caused the higher scores? No way. Maybe those students also started studying more on their own. This is a huge part of the S for specifics. Stick only to what the graph shows you, not what you think it means. Okay, you've got the core technique down. You're running taps like a pro. So now, it's time for the advanced training. Let's talk about the common traps that you might see on the test. We're going to learn how to spot them and, more importantly, how to disarm them so they have zero power over you. All right, trap number 1 is a total classic. It's called the non-zero y-axis. You look at the graph on the left, and it looks like a huge, dramatic difference between those bars, right? But then you look closer, you use your A for axis step, and you see the y-axis doesn't start at 0. It starts at like 100. All it's doing is zooming in on a tiny difference to make it look massive. The image on the right shows what's really going on. This is why checking your axes is your #1 shield against these kinds of tricks. And there are others to watch for, too. Keep an eye out for uneven spacing on the tick marks. Sometimes they'll put 2 different y-axes on one graph to try and trick you into comparing things that can't be compared. And a big one, never, ever assume you know what happens outside the edges of the graph. The defense against all of these is the same. Just run your TAPS checklist. It protects you every single time. Okay, we're on the home stretch. Let's lock all this into your brain with one final pre-test rehearsal. Think of this as your warm-up lap. This is your chance to run the TAPS playbook all by yourself, exactly like you're going to do it on test day. Okay, here it is. A bacteria culture grows from 400 cells to 700 cells, and it does this in 3 hours. So what is the average growth rate? Go ahead, run TAPS in your head right now, find the change in the number of cells, you know the change in time, and then just do the division. I'll give you a quick second. Did you get it? The answer is 100, right? The change in cells was 700 minus 400. That's 300. The time was 3 hours. 300 divided by 3 is 100 cells per hour. If you nail that, you've officially got this system down cold. And there you have it. That's the entire playbook. You now have a systematic, repeatable tool to walk into that test and just dominate any graph they can possibly throw at you. No more anxiety, just confidence. You've completed the training. You got this. Go get it. Fantastic work today, team. So how'd you do on that bacteria problem? Drop your answer down in the comments. I'm really curious to see who got 100 cells per hour. And hey, let me know, which step of TAPS, T-A-P or S, do you think is going to be the biggest game changer for you? If this section helped you out, hitting that like and subscribe button, make sure you won't miss our next training. We'll see you then.